Well, welcome. My name is Dr. Joel Brandt. I'm a vertebrate biologist here at McMurry University, and I'm here to talk to you today about National Fossil Day. And so when we talk about fossils, fossils are the remnants of dead organisms that are in the rocks and layers that are underneath our feet. So how do fossils actually form? Well, I have here a non-fossil thing. This is a mole, an eastern mole that currently lives here in this area. And when things die, they fall on the ground. If they fall into a lake, it's usually a better thing for fossilization. But the soft tissue, like the fur and the tissue and the organs, they won't fossilize. They will eventually rot away and go away. But the hard tissues, like this little skull I have here, which comes from this individual, that may stick around and can turn into rock given time. So what happens with a fossil is first the animal dies, the soft parts rot away, and you're left with the hard parts that can then be buried and turned into fossils. So the first thing is it has to be covered over with a layer of dirt or sediment. If this happens in a lake bed or an ocean bottom, that's usually better. We get a layer of mud that covers over it. And then over time, as more and more and more sediment layers cover over this skull-bearing layer, you can get more and more weight, which adds more and more pressure. And that over time, that pressure can actually compress that layer of mud into a layer of rock. And the bone that is embedded in that layer of mud and rock can also start to degrade over time, but be replaced by minerals. And so other minerals, usually carbon minerals, are gonna add into and replace the bone that's here. The end result is over eons, over millions of years, eventually weather and erosion can wear away the rock layers above this fossil until eventually this little bony fossil will be on the surface of the earth. It'll be rock, not the bone that I have in my hand, and we'll have a fossil. And it looks really, really interesting. Now I have several layers of fossils that are out that come from different areas of the earth, but if you look at them, most of them, they have a layer of what looks like rock background or matrix, and then you have this animal-looking thing in them, or a plant-looking thing in them. Most of the animals that we're going to find in this area, around Abilene in the Big Country, for the most part are going to come from two geological time periods. If I go south of town to where I have the bluffs that we see just south of town, those are going to be made of, in the Cretaceous period, mostly limestone rock. At the time that the Cretaceous period was in this area, well, Cretaceous period, it's about 65 million years ago to about 120 million years ago. This area was all underwater. It was an ocean. And so we have a lot of diatoms, we have a lot of marine invertebrates that are on the bottom of the ocean. One of the common ones is what I've got in front of me, it's called a crinoid, and it's a relative of the echinoderms, the starfishes that are out there. And so these guys were common in the Cretaceous ocean, and so we have them all over south of town in those bluffs, and you can see this is a stalk of a crinoid, and it's not the actual hard, spiny test that we think of with a sea star or something. This has actually been completely replaced by rock. It maintains the outer covering, the outer features, but the inner features are just rock. There's no internal anatomy that I can see. But that's a stalk for one of these crinoids. This is a fossil from Italy. It's got crinoids all over it, but you can see it's got that muddy background. And so this is what we find south of town. North of town, we get a different fauna. The Permian period is what it is. The Permian period was about 270 million years ago, so this is before the age of the dinosaurs. Most of the Permian rocks are going to be reddish because of all the iron that's in the soil, and so we have what are called red beds of rock. At this time period, 270 million years ago, this area was high and dry. We were in a terrestrial environment. There were some freshwater streams and some lakes, but mostly we have a terrestrial vegetation, and we start to have some pretty interesting terrestrial vertebrates. Two vertebrates that I think are important to note. One is a little amphibian or reptile thing called Seymoria. Seymoria was actually a little thing that was found near the town of Seymour, which is north of Abilene. And it is thought to be a transitional fossil between amphibians and reptiles. So at one point it was grouped in with the reptiles. Now we think of it more amphibian. it's a transitional fossil between the two, and it was found not far from Abilene, Texas. Another bigger one, which is a little bit later, was this bigger thing called Dimetrodon. Dimetrodon was a sailback reptile. It's also known as a synapsid reptile. It is thought to be transitional, or an early transitional form, between reptiles and mammals. And the Dimetrodons that we find in the museums at the National Museum and at the American Museum in New York are from Texas, are from the Wichita Falls area. And so those are the types of animals, the types of things you can find north of town. But by far and away, if you're looking in our area for fossils, you're going to find small invertebrates. So I've got some gastropod shells, some snail shells. We have some things called trilobites, which are early insect type things. This is what you typically find in this area. You're not going to find large dinosaurs in the Abilene area. We were talking about how fossils formed, and I mentioned several fossil species that are interesting. But when people were first starting to find these fossils, usually right about the 1800s and 1700s, we were asking, where do these fossils fit? How do they fit within what we already know? We knew about mammals, we knew about birds, we knew about all the different types of reptiles. Where did these fossil things fit? Because they didn't look like anything that we currently knew about. One of them, Samoria, was found in the early part of the 20th century. We know that it fits down here on this particular phylogenetic tree, down here on the transition between reptiles and what we would call amphibians. And so it fits down here. We know that now. At the time, we thought it was one of these reptile groups. We also know Dimetrodon, which was found also here in Texas near Wichita Falls. Dimetrodon is on the line that eventually gives rise to the mammals. So we think of it as a transitional fossil between mammals and reptiles, but at the time, we thought it was a big old reptile. We thought it was a big old dinosaur looking thing. In fact, because it occurs at a time period 270 million years ago that was before the dinosaurs, we thought it was a precursor to the dinosaurs. We now know that's not true, but we thought that at the time. And so then we started finding these dinosaur things. Where do the dinosaurs fit? Where do these big, monstrous reptile looking things fit? Well, we now know that they fit right here. We have the, I gotta spell it right, Saurischia, and then we have the Ornithischians. There we go. There should be a C there. And then we also have the flying dinosaurs, or the flying reptiles, Pterodactylus. Pterodactyl. Close enough. And so we found all these things that were really different that didn't seem to fit anywhere else on this list. But now, using modern techniques, I know looking at the bones or the fossil bones that were preserved, that these guys are all somehow related to each other, and they're also similar to the crocodiles. And we also know that these guys gave rise to the birds. We know that now, so that birds, I like to say birds are living dinosaurs. All this from the fossil record.